Hello, welcome to this video for Comp 6259 Advanced Game Design at the University of Southampton. My name's Dave Millard, I'm one of the lecturers on the course, and in this third video we're going to be having a look at procedural content generation for game scenarios, and in particular for levels. So far we've managed to create our game space. So we've looked at mazes, we've looked at terrain, we've looked at rooms, but how do we turn it into a level? How do we turn it from a kind of a plain space into something that's challenging and fun to play through and engage with? How do we tame the randomness and make it feel less bland? Well, it's worth thinking about what we're aiming for. So in the games course, we looked at difficulty and we talked about flow. We talked about this idea that flow is when skill, the player's skill, and the difficulty of the task they're engaged with are kind of in perfect balance. If difficulty is too high for the level of skill, then players become anxious. If it's too low for their level of skill, then they become bored. So flow is that space where the game that they're engaging with is as cognitively challenging as they can manage. In other words, they're fully engaged in that process. So in fact, we're not after a kind of a continual gradual improvement. We also saw how what actually we want to do with perceived difficulty is kind of have this sawtooth structure, where the beginning of level 2 is slightly easier than the end of level 1. And that means that we end up with this dramatic rise and fall, which is very satisfying to players and gives them that little bit of breathing space as well between kind of these bursts of action. So, what are we trying to do? Well, first of all, we want to try and make sure that the levels that we're generating are actually possible, right? So we want to make sure that there's a guaranteed path through the level and that whatever the win conditions are, that is achievable by the player. So that's a kind of a requirement of our level design. We also want to make it appropriately challenging. So we might think about where we put enemies or pickups in the space. We might have certain placement rules for where they can go that make sense. And we might want to have some kind of weighted frequency so that certain types of enemies appear more or less often, certain types of items appear more or less often. And we also want to try and make it memorable. And it's quite difficult to do that with procedural content generation. So one of the ways that you might approach that is you might want to use a particular set of templates or have a pre-designed set of designed set pieces that you can drop in at particular points. So for example, the original Diablo did this. They had a set piece for each level of the dungeon underneath Tristram. So for example, at the end of level 1, you came across the Butcher's Den. And the Butcher was a kind of a boss that you would have a fight. This was randomly placed in a procedurally generated dungeon, but as a piece of content it was pre-designed to give you that peak at the end of the first level before you progress to the next one. So all part of that sort of sawtooth philosophy. Now what I'd like you to do is to go off and have a look at a GMTK video called How and Why Spelunky Makes Its Own Levels. Now GMTK does a really good job here of having a look at Spelunky and going through the algorithm that Derek Yu uses to generate those levels. So I want you to go and have a look at that video, and while you're watching it, think about the ways in which difficulty is balanced in Spelunky. So pause this video, have a look at that one, and then come back in just a second. Right, I'm going to assume you've watched it. This is all about design versus randomness. So the question is, what does Derek Yu do to tame the chaos of randomness? So if you just randomly populated a Spelunky level with rocks and ladders and crates and gems, it wouldn't be very satisfying at all. It would be just sort of forcing your way through a porridge of material. So what does he do to try and make sure that the experience of the player is good? Well, first of all, he has a guaranteed path through the 16 by 16 grid of rooms. So he wants to make sure that the level is achievable, that you can get to the exit along the way. He also has placement rules for gems and crates and monsters. So they only appear a certain number of times, that they appear in certain places. And he has a weighted frequency of item types. So there are items in the game which are very rare, and therefore they are a particular reward to you, so you should obviously come across those less frequently than item types which are common. And finally he uses a set of pre-designed room templates to try and make some of those cells more interesting, and he has those arranged into different sets. So he has a set for landings, a set for corridors, a set from for drops, so where your ideas are coming from above, and a set for kind of non-critical things that are outside of that critical path. And then what he does is he has some random additions to those to add some variety to the process. So what Derek Yu's doing is essentially the set of things we outlined earlier on. He's got a guaranteed path, he has placement rules, he has a weighted frequency to try and make sure that powerful or exceptional things don't get dropped too readily, and he has a pre-designed set of room templates to add interest. So one of the key things I wanted to draw attention to was a comment that he made that what he's trying to achieve is a fun and engaging level, something much more valuable than realism. Everything you do when you're thinking about procedural content generation of levels is all about trying to give the player a good experience, trying to make sure that what they're trying to do is achievable, but engaging and fun. One of the things that we have with procedural content generation is that we're trying to manage difficulty just like we are when we're doing normal design. But with PCG, we're trying to do it algorithmically. So if we think back to something we talked about in the last course, which is that the perceived difficulty that the player has is actually made up of several components. There's an absolute difficulty of the game, and then as a player progresses through the game, you provide them with power-ups or they level up, and you give them things to help them meet that challenge, and that results in a sort of a relative difficulty. But also that the player improves as they play the game. They get more skilled. So the in-game experience also results in a perceived difficulty. And when you're doing procedural content generation, you essentially are altering these first two things. You can alter the absolute challenge, and you can alter the player's power, right? So to try and make the relative difficulty appropriate. But PCG also gives you an opportunity, because the in-game experience that the player has, when we're designing up front, we have to assume a certain level of progress. So we assume a certain level of skill in our players. But when we're doing things procedurally, we have an opportunity to alter that. In other words, we could also think about how we might manage perceived difficulty adaptively. In other words, could we monitor the skill of the player and then feed that back into our algorithmic process? So if the player is doing really well, we increase the challenge, and if the player is struggling, then we ease up and make it a little bit easier for them. This is known as adaptive difficulty, or sometimes dynamic difficulty. And in adaptive games, essentially the idea is that we have a component of the system that is monitoring the player performance, that uses that information to adapt the game based on that performance, and then measures the effectiveness of the adaptation, and that feeds back in to monitor the performance again. So we have a kind of a feedback cycle where the game is reacting to the player in order to try and keep them in flow. We can also bring some stuff in at the beginning. So for example, the player might have some preferences. Do they want to play on hard mode or easy mode? And we also might have some idea of different types of players that we're trying to cater for. So what we might be doing in our monitoring is actually trying to pigeonhole players into one of a number of different sort of player stereotypes. In online systems, we can go even further than this, because we can look at the effectiveness of the adaptations, we can look at what way that players are behaving, but we can do that across all instances of all games. So we can take the collective behavior of all of our players and use that to kind of understand the way in which our adaptations are being successful or unsuccessful, and feed that back into the process as well. This is quite rare, but it's possible. So if we think about some games and what they actually do, Breath of the Wild is a really popular game that uses dynamic difficulty. So in Breath of the Wild, what it does is it keeps a current kill count for each of the different monster types that you face. And then it increases the strength of that monster type in proportion to that kill count. So in other words, the more things of a particular type that you kill, the harder new things of that type will be to kill. It also has a player preference in that you can play it on hard mode, in which case it gives a bump to all of the kind of levels of the enemies. The Left 4 Dead series are very, very well known for having dynamic difficulty. In Left 4 Dead, it actually looks at lots of different aspects of the player's current situation, their current health status, the skills that they've gathered, where they are in the game, and then it adjusts a whole variety of things. So, for example, the health pickups, the mob spawning, the strength of different enemies. And what it's trying to do is essentially keep you on the edge, so you're always in the position of just being able to survive. Now, Left 4 Dead has multiple player characters, so you have a number of choices, and it has different game modes, so those would be player preferences. It doesn't so much have models of player types, but it does have a model that feeds into the the monitoring of performance, in that Left 4 Dead understands the structure that it's trying to go for in terms of the dramatic arc. So it knows it's going through a build-up stage, it reaches a peak, and then there's a relaxation stage afterwards. And that will feed into the monitoring of the player performance and the adaptation of the game to the individuals, so that the sorts of things that are happening are appropriate for the place that the player is in that current sort of dramatic arc. Now, there are some drawbacks to dynamic difficulty. So first of all, some players absolutely hate it. They want to have an absolute experience. They want to be able to compare themselves equally against other players. So you may want to allow players to switch it off. The second problem is that it is possible to exploit dynamic difficulty systems. So in other words, a player can play their game not to their best ability, but in a way that takes advantage of the system to get them as far as they possibly could. You might call this kind of player hustling, and you have to think about whether you care about that or not. There are also interesting problems with tasks that can't be scaled. So for example, if you have a puzzle which only has one solution, or there's only one way to get through, then there is no way to adjust the difficulty of that. So you have to start thinking about whether all aspects of your game can be adjusted. Otherwise, someone who's having a game that's been made a lot easier for them may suddenly come across something which is disproportionately difficult. You also have to be a little bit careful about your system to make sure it doesn't lead to absurdities. So they might be quests that are impossible to fulfill, or something called rubber banding, which is when something is scaled so much that it becomes ridiculous. So kind of, very minor creatures, but you've just killed so many of them that now that they are, one of the most powerful godlike creatures in the game, are almost impossible to kill. Perhaps most importantly, some people argue that dynamic difficulty detracts from good level design and can affect pacing. So, in other words, that what it does is, instead of having that nice sawtooth approach, that it sort of smooths out those edges and makes a more bland experience. That's why Left 4 Dead actually has a whole game director whose job it is to balance all of those factors, and who understands where you are in the dramatic arc in order to make sure that you get an interesting rather than a bland experience. So in summary, across these three videos, we've looked at procedural content generation in general, we've seen how it can be done at design or runtime, and we've said that it's generally speaking a kind of a benefits analysis where you've got benefits for cost, variety and space on the one hand, but on the other hand you require increased expertise in new areas and you have a loss of creative control. We also looked at Hendrix's pyramid of procedural content generation in games, and we picked a couple of those things to explore in detail. But of course, there's an enormous number of different algorithms and processes and ways in which you can do PCG. We then, in the second video, looked at game spaces. We looked at a number of algorithms for creating indoor spaces like mazes and rooms and caves. We looked at outdoor spaces, terrain, and we also looked at L systems for vegetation, and I also gave you the example of buildings. And then in this video we've looked at game scenarios and in particular levels, and we've seen how there are some key things you want to try and do, such as maintaining a guaranteed path and using placement rules and weighted frequency in order to try and achieve flow. And we've also seen how you can use templates or set pieces in order to make more memorable levels, or even to create kind of that sort of sawtooth rise in difficulty again, where you get some climax in the level that becomes a set piece. And finally, we looked at adaptive difficulty, sometimes called dynamic difficulty. We've seen how that process works, but also some of the pros and cons of that approach. So thank you very much for watching these videos. I hope they were useful to you, and I look forward to seeing you in a future video.